Hello and welcome back to another LeetCode problem of the day. Today it's 812, largest triangle area. And this problem is we're given an area of points on the xy plane where each point has an xy coordinate, and we should return the area of the largest triangle that can be formed by any three different points. And there's some requirements in terms of the precision to which we should answer that. We're going to be dealing with floating point numbers. And yeah, there's a constraint on the length of the area of points that we're getting. Of course, for random analysis, we're going to ignore the fact that there's an upper bound. Otherwise, everything will be constant time and constant space automatically. And we're given some constraints on the coordinates. So they are between -50 and +50. Now, this is kind of well, I would say this is probably not a good interview problem, simply because you have to know how to calculate the area between three arbitrary points on the plane. If the points, it doesn't say here that the points are given in integer coordinates, for example, and it doesn't say that we're giving like triangles that are aligned with any of the two axes. So how do you calculate the area between any 3 points A, B, and C? So how do you do that? Well, I did some digging and I wouldn't have known myself, but apparently there's a way to calculate that using the determinant. So I found here on Khan Academy a nice video that explains how to interpret determinants as an area. And it turns out if you have 2 points, you can actually calculate the area of the parallelogram that is spanned by those two vectors that lead to those 2 points. So, and if you then halve the area, you would get half the determinant, you would get the area of the triangle. Now here, our first point always start at the origin, but of course, we could shift our other 2 points to the so that by however the third point is shifted from the origin, so to create this scenario, and then we could just use this determinant. Turns out there's also a way of how you can directly calculate the area using a determinant without shifting any of the points coordinates, and that is by calculating the determinant of this 3x3 matrix, where we see the coordinates of every point and one column here, and then again taking half of it. So that is kind of the formula that you have to know to be able to solve this problem, I guess, without a lot of hassle when you want to try to calculate the area. I know you could do other trickeries where you think that this is like a square, and then you calculate the total area, and then you subtract the 3 corner sides. Corner areas. You could do that as well, but that would make things complicated. So if you look up a solution, that will involve the determinant. And I looked up how to do that. So here we see the formula for the determinant, and this is basically how you calculate the determinant, right? I don't know if you know this, but basically you add up the diagonals that go from top left to bottom right. So x1, y1, 1 plus blah, 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 blah. And then you subtract the ones that go into the other diagonal direction. Yeah. So, but we're not going to do that. So instead, well, if we have a function that can calculate the area, and then we give it 3 points, ABC, we want to return that area. And let me just format this formula different screen. So that would be this. So we're going to return, so this would be our, see, the points are given as arrays, right? So 0.1, 0.2, 0.3. And I'm just going to do this real quick. So this would be the x value of the first point. X value is at index 0 times I'm just going to reuse this. The y value of the second point minus the y value of the third point. And then we subtract the x value of the second point times, here we go again, the y value of the first point minus the y value of the third point. And finally, we're going to add the x value of the third point multiplied by y value of the first point minus the y value of the second point. So yeah, so that should be the formula. Yes. So we have, this looks a little bit crowded, doesn't it? So we're going to say area equals this, area minus equals this. And then finally area plus equals. Yes, 1, 2, 3, 2, 2, 1, 3, 3, 2. Is that correct? Double checking. 2, 3, 3, 1, 1, 2. And here we have the x1, x2, x3, right? We do have that. x1, x2, x3, and then multiplied by, let's see, y2 minus y3, y1 minus y3, y2 minus y3, y1 minus y3. And then we have y1 minus y2, the final one, y1 minus y2. Yeah, so so that's the formula to calculate the area. Yeah. I mean, if you were to do this in an interview, I mean, this would be great distraction from your problem-solving abilities, I guess. This is more like a math quiz or puzzle at that point. I don't know if anybody's asking that, but maybe some companies are. I don't know. Yeah, so well, now we still have to find out which is, you know, what's the largest triangle, and we know we are going to be given like at least 3 points, maximum 50 points. So we could iterate over all of the points, correct? So we could have like an O of n to the power of 3 solution, and we just need to return the largest area, which means we just need O of 1 space to store the results. So let's implement that solution, O of n to the power of 3 time and O of 1 space. And max area is 0. That's how we start. Now, something that we didn't really see explained is whether, you know, some of these points are the same. We just know that we're giving an area of points, but we don't know if these points are necessarily all different. But we need to make sure that when we pick 3 points, that they have different coordinates, right? So that is something that we have to check. Let's start with our outer loop. And because the order in which we have the points doesn't matter, we just make sure that we never pick the same combination of points in a different order again. So our second index over for the second point starts at I plus 1, goes to the length of points, and our inner loop starts from j plus 1 to the length of points. Right. So yeah, we still need to check of whether the points are all different or not. So let's say P1, we're just going to get points. I'm going to change that. Actually, no, I don't have to do that. So P1 is points at position I. Our P2 will be points at position J. If P1 is the same as P2, we're going to skip. because that means the first point and the second point that we picked at different indices of our points array is the same. So they have the same value. And similarly, what we'll do here, say P3 is our points at index K. So if P1 equals P3, we're going to skip, but also if P2 is equal to P3, we're also going to skip. And so the area that we get from these points, we simply use our little helper function, calc area, P1, P2, P3, and then we just remember the maximum. So maybe we find a new maximum, maybe not, but if we find it, we'll memorize it in our return variable. My area, all right. So I think that should be all. Let me see. Yeah, I think that should be all. And so this should calculate area. Well, so this is for calculating the determinant, right? So we still need to divide it by 2. And we're going to make a floating point division, not an integer division. And just going to make it explicit by saying 2.0. We don't need it, but that just makes it visually more obvious. So I'm just going to check the formula one more time. So that's the determinant. And then, yeah, we have to take half of it. Oh, and apparently we also have to take the absolute value of it to ensure that it's a non-negative. Good that I checked. So we're going to return the absolute value of area and then divide it by 2. So let's run this, see if that works. So we have an invalid character here. Oh, and that is because we copied from the website. And then I think it uses the Unicode hyphen instead of the minus sign. I think. Invalid character. Yeah, there you go. Still invalid character. Area equals minus equals. Maybe the closing brackets. Maybe they are wrong. Maybe it's the multiplication sign. I'm not sure. Let's try this again. If this doesn't work, we just have to probably type it again. Okay, now it works. There you go. Yes, Unicode errors. Okay, cool. So that seems to work for the test case. Let's submit this and see if this is a solution that LeetCode is going to accept or if the runtime is long. So actually it works. Nice. So we're on a streak here. And as we like to do, let's see if there are other approaches that we could take. Let's select Python ones. And let's see if we find something that has a runtime analysis. 3 approaches, easy explanation. Let's see about that. Shoelace formula with determinant. Distance Heron's formula. So you see, okay, this is the same as ours. You see that you really have to know some math to do this kind of stuff. And I don't think anybody knows this automatically. So I don't feel bad for looking it up. And all of these solutions are of n to the power of 3, where n is the length of the list with the points. Also O of n to the power, the third power. Yeah, I don't know if there's a simple math. Also 3 nested loops. So yeah, so I guess we can't do better. If you do a Google search, you probably find an even more elaborate way of doing that. But this is a LeetCode easy problem. So if it's an easy problem, that's very often a very strong hint that the brute force solution is good enough, or that there might not even be one that is better than a brute force solution. Yeah, so thanks for watching. And I think it's safe to skip this one if you're preparing for interviews. But yeah, it's good to know that these things exist on LeetCode, and Don't sweat it.